can dimensionality be reduced in ML datasets? Imagine trying to find your way through a crowded room filled with hundreds of people. It can be overwhelming and hard to see the clear path. That's similar to working with high-dimensional data in machine learning. When datasets have many features or variables, it can slow down algorithms and make it harder to find meaningful patterns. So, can we make this data simpler without losing important information? The answer is yes, and that's where dimensionality reduction comes into play. Dimensionality reduction is a process used in machine learning to take complex, high-dimensional data and turn it into a simpler form with fewer features. This is especially useful in unsupervised learning, where the goal is to find structure or patterns in data without labeled answers. For example, in clustering or visualization, reducing the number of features helps us see the data more clearly. There are two main ways to reduce dimensions. The first is feature selection, which picks out the most relevant features from the original data. Think of it as choosing the best ingredients for a recipe, leaving out the ones that don't add much flavor. Techniques here include statistical measures that rank features, or methods that evaluate how well a subset of features performs in a model. The second method is feature extraction. Instead of just selecting features, this approach creates new ones by combining the original data. For example, principal component analysis, or PC, transforms correlated features into uncorrelated components that capture most of the data's variation. Other algorithms like t-distributed stochastic neighbor embedding, or t-SNE, help visualize complex data in 2 or 3 dimensions by keeping similar points close together. Uniform manifold approximation and projection, or UMAP, offers a fast way to preserve both local and global data structures. Techniques like Isomap and locally linear embedding focus on maintaining the geometric or neighborhood relationships in the data. Reducing the number of features makes machine learning models run faster and more efficiently. With fewer variables, models are less likely to overfit, meaning they won't just memorize the training data but will perform better on new data. It also makes it easier for us humans to visualize the data, spotting patterns and clusters that might be hidden in high dimensions. In the world of artificial intelligence tools like ChatGPT, DALL, and Midjourney, dimensionality reduction helps manage the complex data these models process. For example, text embeddings or image features are high-dimensional, and reducing their size helps these models generate outputs more quickly and accurately. Productivity plugins that use AI also benefit from this process, making data handling more efficient and speeding up responses. It's important to remember that applying dimensionality reduction carefully is key. If important information is lost during the process, it can lead to biased or inaccurate results. Transparency about which methods are used and how they affect the data is essential, especially when deploying AI systems. So, to answer the question directly, yes, dimensionality can be reduced in machine learning datasets. It's a powerful tool that helps make data easier to work with, speeds up algorithms, and improves the clarity of insights. It's a vital part of the machine learning toolbox, especially when dealing with complex, high-dimensional data.